everyone, welcome back to our channel. Today we'll be solving a Physics 7C practice problem about spherical mirrors and images called Lucy and the Candle. Remember, if you find this video helpful, please subscribe to our channel and leave a like. Your support helps a lot and we really appreciate the feedback. Okay, here's the problem. Feel free to pause the video to copy the problem so that it's easy for you to follow along. Lucy stands 30 centimeters before a spherical mirror holding a 5 centimeter tall candle. Looking into the mirror, she sees an image of the candle that is right side up. However, the image that she sees is 7.5 centimeters tall. The questions we want to know are, what is the image distance? Is this image real or virtual? We want to explain why we say what we say. We want to calculate the focal length of the mirror. What is the radius of curvature? And is Lucy's mirror convex or concave? We also want to know, if Lucy starts to slowly walk backwards away from the mirror, and the image of the candle grows larger and larger until it finally disappears, how far away is Lucy from the mirror when the image of the candle that she sees in the mirror disappears? And then part 5 is, if she stands 30 centimeters further back from the point that we found in part 4, where should she look to see the image of the candle? What sort of image is this? Okay, so our problem deals with mirrors and images. So the first part of our problem, deals with mirrors and images. And our first question is, what is our image distance? So I went ahead and wrote down some of the equations we need. So the magnification equation, written here in blue, m equals the initial height of the height of the image over the height of our original object. Magnification also equals negative of the image distance over the object distance. So what we want to find is the image distance I. This is what we're looking for, and this is the image distance. So this is kind of just plug and go. So we have the original object height is 5 centimeters, and the image height is 7.5 centimeters. And this equals negative the image distance over the object distance, which is 30 centimeters. So solving for the I get I equals negative 7.5 over 5 times 30 centimeters. And this ends up being negative 45 centimeters. So what that's saying is, if this is Lucy, and she's standing here holding a candle, there's my little candle, and here's our mirror. If she's 35 centimeters away, then this being negative 45, since we're measuring this side to be positive, this side is negative. So we will see the image at this negative 45 centimeter mark, taller than the original candle. That's supposed to be a candle there. Boom. Okay, so this is what we get for our answer, negative 45 centimeters. Okay, so for part B, let's do part B. That was part A. Part B, we want to know if the image is real or virtual. So the handy way to remember this is, if the image value we get here is greater than 0, it's real. And if the image value is less than 0, it's virtual. So in our case, our I is negative 45 centimeters, so it's virtual. And a way of remembering that is, if our mirror, which we don't know if it's concave or convex yet, if our mirror is sitting here and the light ends up going behind the mirror, or our image ends up behind the mirror, there's no way for the light to pass through this lens. It's only appearing to be back here. It's only real if we can actually touch the photons that bounce off of it to where the image is at. So if we get an image in front of here, we know that the light has bounced off of this lens to make it real. If it's behind the mirror, there's no way for the light to pass through that mirror to actually get to this position, so they're virtual. Okay, part C. We want to calculate the focal length of Lucy's mirror. So this equation is 1 over the object's distance plus 1 over the image's distance equals 1 over the focal length. So since we're trying to find the focal length, we're going to say F equals 1 over the object plus 1 over the image to the negative 1. So I just I multiplied the F over and divided this whole thing over to the other side, which is why it's to the negative 1. If I plug in 30 centimeters and negative 45, my focal length, so 1 over 30 minus 1 over 45, all to the negative 1, ends up giving me 90 centimeters. So that is our focal length. To get our radius of curvature, we just say R equals 2 times the focal length, which is 180 centimeters. Okay? Now it says, is Lucy's mirror convex or concave? Once again, this is a handy rule. If F is greater than 0, the mirror is concave. If the focal length is less than 0, it's convex. In other words, if our radius is a positive value, that means the mirror has to be curved in a way that if it made a whole circle, the radius would be on the left-hand side. If it's convex, it would be curved the other way so that the radius of the entire circle, or the center of the entire circle, would be on the negative side. So the focal length being positive means concave. Focal length being negative means convex. Okay. Now let's take a look at part D, or part 4. Lucy starts slowly walking backwards away from the mirror. She observes the image of the candle growing larger and larger when it suddenly disappears. So using our equation from up here, 1 over 0 plus 1 over I equals 1 over F, we're saying the image goes to 0, right? We want to know what happens when the image disappears. Or, I'm sorry, when the image goes to infinity. It gets bigger and bigger. So as the image goes to infinity, 1 over infinity is 0. So what we get is 1 over the object equals 1 over the focal length. We know the focal length, the mirror's focal length isn't going to change. What we're changing is how far away the object is from the mirror. And to get this, since we know the focal length is 90 centimeters from part C, the object must be at 90 centimeters. So our object must be at 90 centimeters. Okay. So the final part, part E, part F, whichever you prefer. If she stands 30 centimeters further back from here, so her new point is at 120 centimeters. So she took 30 centimeters back away from the 90 centimeter mark. Where should she look to see the image of the candle? So now she's outside of the focal length. Let's see what happens. If we want to know where the image is going to be, what we want to find out is, using this equation again, we're going to solve for 1 over I. So 1 over the image distance equals 1 over the focal length minus 1 over the object. We know the focal length because the mirror hasn't changed, and we know the object distance because we solved it in the previous problem plus 30 more centimeters. So we get 1 over 90 minus 1 over 120. And that gives us an image distance of, if we solve, remember this is 1 over I becomes 360 centimeters. So what does that tell us? Since I is greater than 0 now, if we remember part B, if I is greater than 0 now, that means it's in the front of the mirror. That means it's on this side now, which means we can actually see the physical photons. We can actually interact with the physical photons bouncing back to create our image. That means our image is real. So I greater than 0 is real. So that is our problem. If this was helpful, please leave a like, and I will see you in the next video. Bye!